it's true. When something exceeds your ability to understand how it works, it sort of becomes magical. And that's exactly what the iMapper is.
When you look at the iMapper, the way that it goes through its terrain, the way that it's built, the way that it's designed, you just think to yourself, well, of course, it must have been that way. That's the best way to do it. How else would you make an iMapper?
The thing about the iMapper is, I don't have to change myself to use it. It adapts to me.
With the Teensy, we really do get a great deal of power in our robot. Using basic Arduino software on board, as well as a high number of interrupts that it has, and paired with an H-bridge, you get a great deal of motor driving power in a very small and efficient package that will work with any system needed. This here truly is the heart of our driving system.
When you hook up the connector, you get a point cloud of everything the Connect sees in 3D. This is essential to setting up a local map. You're able to take everything the Connect sees as empty and every space that it sees as blocked and put it on a local map in relation to the robot. From the local map, we can then translate all the empty blocks and all the obstacles to the global map. The global map will then show all the obstacles as green blocks and the C-space as shades of red blocks. Empty blocks will be white. For every block that's seen as an obstacle or wall, we need to set up C-space. C-space is set up in a way where we have high probability and low probability of the robot hitting the obstacle if it travels through the C-space block. Even though we do not want to have the robot travel through C-space, we still set this up in the event that the robot is surrounded by C-space. That way the robot can pick the smallest probability C-space that it sees and travel through it in hopes that it will not hit the block. This allows us to make sure that the robot can always move through its environment and still be safe while doing so. How we implemented Wayfind is very simple. First, we set up a function that looked at a block and put into a queue all its neighboring blocks. Then we started at the goal and we stepped through for each block and found its number. Finally, we started